Welcome to sixth video of analog electronics lab. In this video we shall see the working of Arduino board. So the first experiment is write an Arduino script to sense the signal from the temperature sensor and to turn on the DC motor if the temperature exceeds 40 degrees centigrade. Now in this particular case we are using a sensor uh, which is used to sense the temperature, that is LM35. The actuator is a DC motor which is operating with 12 volts. The task now is we need to turn on the DC motor if the temperature exceeds 40 degrees centigrade. Now the implementation is done using the Arduino board. So we know that the output voltage of the temperature sensor has got a sensitivity of 10 millivolt per degree centigrade, and the DC motor rating is of 12 volt. So these two are the data that we will get from the data sheet of LM35 and for the DC motor. We know that the sensitivity of the LM35 is 10 millivolt per degree centigrade. Since we are looking for 40 degree centigrade, the output voltage of the temperature sensor at 40 degree centigrade happens to be 400 millivolt. Now let us have some interesting things here. So first thing is that the Arduino should read an analog voltage from the sensor, because as the temperature changes, the output voltage of the sensor also changes. So this is analog in nature. The Arduino board should be such that Arduino we are supposed to connect the temperature output to the Arduino board, which can accept the analog input. LM35 output must be connected to one of the possible 6 inputs of the Arduino board, that is A0 to A5. The analog voltage read varies from 0 to 5 volt, that is the value that is taken into the Arduino board is 0 to 1023, so totally 1024 values. So 400 millivolts corresponds to 81.84. So using this calculation, that is 1023 corresponds to 5 volts. So naturally 0.4 volt corresponds to 81.84 value. So now the red analog value is compared with number 82, which corresponds to 40 degrees centigrade, which in turn corresponds to 400 millivolt that is measured, that is being given by the LM35 sensor. Now, fifth point is, if temperature exceeds 40 degrees centigrade, Arduino should give a logic 1 on one of its digital I/O pin so as to actuate the actuator so that DC motor starts rotating. So if the temperature exceeds 40 degree, the Arduino should give a logic 1 so that the motor runs. So using this specifications to run a motor, we shall have a look at how do we write the code. Now this is how the Arduino board looks like. So we are having these are digital IOs. So this is 0 dedicated for receiving and transmission, and we have 2 to 13 as the digital IO pins. So we have analog input pins A0 to A5 here, and these are some power related pins. So we need to connect the output of the temperature sensor to either A0, A1, A2, A3, A4 or A5. The output from that Arduino will be connected to the actuator, that is motor, either through the relay or directly to the motor from any one of this pin, that is 2 to 13. This is how the pin diagram of L293D Driver IC looks like. It's a 16 pin IC. It has got 4 buffers, non-inverting buffers. So the inputs are 1A, 1Y. This is the input. The output is 1Y. The second input is 2A, that is pin number 7. The second buffer output is pin number 6. Similarly, we have for the third and the fourth one. So it is interesting to see we have 4 non-inverting buffers, whereas we have only 2 enables. So this enable pin number 1 will going to enable 2 buffers, that is 1 and 2, and this enable pin will going to enable two more buffers, that is 3 and 4. And it is interesting to see there are two VCCs here. So pin number 16 is VCC1, pin number 8 is VCC2. We shall have a look at what is the function of this VCC1, VCC2 in the next slide. And we are also having 4 heatsink grounds, heatsink and the ground, that is 4, 5 and 12 and 13. So suppose if you are using buffer 1, we need to ground pin number 4. If you are using buffer 2, we need to ground pin number 5. Similarly, if it is the third buffer, we need to ground 12. If you are using the fourth one, it is 13. It is better to ground all of them so that you can use any of the buffers. Now this is what the pin description says. 1, 2 are the enable, that is pin number 1 is the enable pin for both channels 1 and 2, and we have the driver inputs as 2, 7, 10 and 15. So as we saw in the pin diagram, 2, 7, 10 and 15 happens to be the inputs for the driver. Similarly, we have the driver outputs, that is pin number 3, 6, 11 and 14. So this 2 is the input, 3 is the output, again 7 is the input, 6 is the output, 10 is the input, 11 is the output, and again 15 is the input, 14 is the output for 4 channels of the driver IC. And for the channels 3 and 4, we have the enable pin, that is 3, 4 enable, which is 9 here, and we have ground, that is 4, 5, 12 and 13. Now please have a look at this VCC1. This is pin number 16. It's a 5-volt supply for internal logic translation. So this is required for the IC. Just have a look at this VCC2, which is pin number 8. So this is power VCC for the drivers, so which can vary from 4.5 volt to 36 volts. So this is the voltage which is to be usually given from an external power supply to your circuit diagram. Now let us have a look at how does the entire circuit is connected. As we now know that this is LM35, so please look for the data sheet terminals for LM35. So one pin is connected to VCC, the other one is grounded, and one more pin, that is the output. So output should be connected to the Arduino A0 to A5. Anyone can be connected as the input. The digital IO is connected to the driver buffer. So this is pin number 2 is one of the input. So we are connecting pin number 1 to VCC to enable the first and the second buffer, second channels. And you can see pin number 16 is connected to 5 volt, and pin number 1 is also connected to 5, so that we are enabling channel 1 and channel 2. Pin number 16 is for internal operation. So this pin number 8, which is VCC2, is connected to 12 volt, because 12 volt is actually required to drive the relay as well as the motor. So that's why this 12 volt is connected to this VCC. The output is connected to the relay. So now we can see 4, 5, 12 and 13 are the ground heat sinks, so they have been grounded. So please have a look at here. This plus 5 volts is connected from the Arduino board itself, whereas plus 12 volt is connected from an external power supply, because we need to have more current for the motor to run and for the relay to operate. So this plus 12 volt is actually coming from an external power supply. More importantly, all the grounds of the Arduino board and the external power supply have to be shorted. So this is a must thing. Suppose if you don't short the grounds of the Arduino as well as the external power supply, so the relay won't operate, as well as the motor will not run. Now this is one more possible connection. Without using the L293D, we can also energize the coil using a transistor. So that is, we have a BJT. So make sure that you are connecting the NPN transistor, which is maybe you can use SL100 or CL100. Please make sure that you are connecting an NPN transistor. The digital output of the Arduino board is connected to the base through a resistor of 10 kilo ohms, and at the collector we are connecting one end of the coil. The other end of the coil is connected to plus 12 volt, which is an external power supply, and we are making this connection. NO is connected to plus 12 volt. The common is connected to one end of the motor. The other end of the motor is connected to ground. Suppose if the temperature exceeds 40 degrees centigrade, so then this Arduino gives a logic 1, which gives a sufficient base drive for this transistor. So this transistor turns on, which makes the current to flow through this coil, which will make this common connected to NO, so that this motor starts running. So this way, when the temperature exceeds 40 degrees, so the motor starts running. So this is a third possible choice. I can see the difference between the third choice and the first choice is, so just have a look at the first choice. The first choice, you connected the output of the buffer to the relay coil. So this relay was making a connection. This common was connected to, common will be get connected to NO, so motor starts running. Just have a look at the third choice. That is the similar type of connection. Instead of connecting pin number 3 to the relay, you are directly connecting that pin number 3 to motor. Since it's a DC motor and it requires only 12 volt, which is well within the rating of VCC2. You might have seen that VCC2 can be varied from 4.5 volt to 36 volts. Since 12 volt falls within 36 volts, I can directly drive a motor using the L293D IC itself, so that I can eliminate the use of a relay for this particular experiment. I can directly connect the motor, one end of the motor to pin number 3, the other end can be directly grounded. So this is one of the possible Arduino script to make sure that the motor runs when the temperature exceeds 40 degrees centigrade. Now so now you are doing an analog read operation and make digital write. So we are initializing, we are considering a value integer by name value, and it is initialized to 0, and we are considering a motor, and which is assigned a value of 12. We have two infinite loops. One is for setup and other is for making that output to run. In the setup we have pin number 12 as the output, and we want to see what is the output voltage from a LM35, that is temperature sensor. So that's why we are opening a serial port. Now I can see we have a infinite loop, that is a void loop here. Now this analog read from 0th pin of your analog input will be read, and it will be assigned to val. So now analog voltage is read from LM35 and the value is available at val. So this serial.println will going to print the value of going to print the value of val, that is the value that is read from the LM35 in next line. For whenever there is a change in temperature, that will be updated on your serial print. So as the statement says here, if the value is greater than or equal to 82, you are writing a high. So this is digital write motor comma high, meaning if this statement is true, that is logically true, so you are writing a digital write, a high value is written at motor. Since motor is nothing but pin number 12, so a logic high value will be written onto the pin number 12. So pin number 12 in turn is connected to a relay or a motor. If it is connected to relay, that relay will be get energized, which will make your motor to run. If you are connecting that motor directly, the motor starts running. The value is greater than or equal to 82. So this 82 actually corresponds to 400 millivolt, which is 40 degrees centigrade. If this statement is false, we are actually writing a digital write motor comma low. This low value will be assigned to motor, so that delay will be the relay will be de-energized, so that motor will be off. So in this program, the red value from the LM35 is assigned to val. If the val value exceeds 82, it writes a high, otherwise it is a low.